Hi, I welcome you all for another session. I think this is for Puneet's session today, but he is quite not well, so I'm taking care of it. Um, Meanwhile, I need your cooperation because I haven't checked the questions. So yeah, uh, let's take a couple of minutes to start. Shall we start, guys? Uh, so I'll share my screen for the first question. Okay, can you all see my screen?
Yes.
Okay, so the first question is construct a string from a binary tree. So we'll be given this kind of a tree, like a normal binary tree, and we need to change into this string form and how this string form is being generated. So for example, this is a node and its left part is 2 and so for and 2's again left is 4. So whenever there is anything on the left or right, it should be in a bracket. So 4 is in a bracket, and similarly 2 is also in a bracket, like for one's node, and right part of one is also in a parenthesis, like this is round parenthesis. So you need to make it like something like this. Before that, actually it should be like this because there are empty two's right is empty, and similarly 3 left and right are empty, but you need to omit all the unnecessary empty parentheses. So it should be like in this form, and if you're generating kind of this as well, this needs to be omitted. And this is also the same example, but here they are saying that we can't omit the first parenthesis pair to break the one-to-one mapping relationship between the input and the output. So it's saying that there is a one-to-one mapping, so that's why they are not removing it. Um, but here they are removing it. So anybody has tried to solve this question? Anyone?
Even having any approach is also fine.
Hey, yeah, hi. So um, I didn't solve, but I have an approach for it. So what we can do is we can write a simple recursive program for it, in which first we will traverse the root node, then we will traverse the left part and then right part. And meanwhile, we will like maintain a string, and in that string we can like append the first root, then left, then right. In that way.
Yeah, that sounds good. Like a pre-order, we can do it because we are coming because the output we need to give it in a pre-order. The only main thing is how we pass the parenthesis over it. That's the main. So what would be the return condition for the for your recursion? What you're thinking about it?
Okay, so if um, the node is null, then we will just add empty parenthesis and return.
Okay. So what? I think I need to. mute some. Okay. So you are saying, yeah, so if the node is null, we need to pass the empty parenthesis. And how about passing the opening and the closing?
Okay, so if the node is not null, then we can first append opening parenthesis, then append the value of that node, and then append the closing parenthesis.
And is it like if we can get this kind of a condition, like we'll be adding the empty parentheses as well? Is there a chance to get this kind of a problem? Like tools write is null. So I'm thinking like something if we can use a stack or a queue, that would also be help. That would also help over here. Like for recursion as well, if we are passing the return at, if the node is empty at every, if the node is empty, then we are passing this empty bracket. Would it be easy to handle this condition? I'm just thinking about it.
I use a recursive function.
Mm-hmm.
Yeah, like just mentioned, if the root is none, we just return the empty string, and we think about several different situations. One of the situation is left. One of the situation is a leaf node. That means the left and the right are also none. In this situation, we will return the string of that number. And another situation is the left node is now none and the right node is none, like the example 1. Like the node of the left node of 2 is 4, but the right node is none. In the example 1, we can just return the string of the 2 and connect and the string of the left parenthesis and the string of the left node value 4 and the right parenthesis and plus the empty parenthesis. Yeah, like the explanation, it will be 2 parentheses, 4 parentheses, and empty parentheses. And the last situation is the left node is none, but the right node is now none. Like the example 2. The example 2, yeah, the node of 2. The left node of the 2 is none, but the right node is 4. Yeah, in this situation, we will put the 2 and empty parentheses and the node of 4 plus 2 parentheses. Yeah, that's my
okay. Yeah, thank you. Anybody have any questions on this approach? Anybody wants to like to be anybody haven't understand this question or any approach? Because I think this would work, recursion would work, because or you can take any stack to solve this particular problem. Like,
So let me ask like one question.
yeah.
What kind of traversal is best suited here? Like, will you guys go with in order, pre-order, or post-order?
I think it would be go for pre-order because we are going from top to bottom.
In fact, it is given in the
It's
question.
pre-order as it is mentioned in the question as well.
Right.
It's a pre-order. It's
Yeah.
mentioned that like we want to print 1.
Yeah,
Yeah.
with the pre-order traversing way.
Okay.
It's written in a question.
Yeah, it's written in the question, but let's say like in the second example. Yeah, it will work. Okay, should be fine.
Yeah. So the only edge case is like if it is, we should not omit this particular bracket. If you are, so if your program is running like this only, your answer is coming in this way, then you don't, and if your parentheses are not coming, then it's okay. But if your parentheses are also coming, then that needs to be omitted. So that's the main question. Like if the recursion you are doing, your empty parentheses are coming or not. Anyone has tried to solve this particular problem if they got something like this?
Can someone share code?
Yeah. Julian has solved it. So can you share the code?
Okay. Yeah.
Like
Uh,
understand, like help us understanding about how you written the code and how it is working. If it
okay.
stop sharing, if you want to share it.
Yeah. I can share my screen.
Okay, sure. 1 second.
Could you see my screen now?
Yes.
Yeah. That's my solution for this question. I use the recursive function. If the node T is empty, I just return the empty string. If the node is a leaf node, that means it's a left node and right node are also null. I return the T value string. That means the full number becomes the full string. Like we just return 4. Yeah. And another situation is left node of T is none, but the right node is now none. It comes to that example 2, like the node 2. The left node of 2 is none, but the right node is now none. In this situation, I return the node of 2 and empty parenthesis and the right node string like this. Yes. Yeah. In this situation, I return the 2 empty and the 4 with parentheses. This is the situation of this left node is none and the right node is now none. And the last situation is like the example 1, this one. The left node is now none, but the right node is none. In this situation, we couldn't add the empty here, so we just I just return the node of T and plus the left node number like 4. You can see here there is no empty here, so we just return 2 and 4 with parentheses. And the last step is return recursively. Each step we will return the T value of string and left T left node and the T right node recursively. Yeah.
Is this
So
solution working? Have you checked it?
yeah,
Oh, okay. That's nice.
yeah.
Yeah. It seems like a good approach. Anybody have any questions? Anyone has tried on using any other approach?
Yeah, I was thinking of the use a stack or a queue to solve the problem, but it's not so easy to solve because you have to thinking about if the node is a left node or right node because they are different solution parsing of the right node and the left node. So I think,
what I am thinking, we need to take some visited part or something like that set as well while going for a stack, and in that stack you need to like go for a pre-order approach. Then you need to go for, first of all, print the node which is on a top, and then left and right. And while you are you need to check if it is left and right is empty or something like that. Then I think that some logic would be there for this. Yeah.
Mhm.
So anyone has any questions? Then we should proceed further.
Okay, I'll stop my
Thank you so
share.
much.
Okay.
Yeah, thank you so much.
There's actually a variation for this one.
Yeah.
If you are already given this order, sorry, the output that we have generated here, can we
This one.
generate the tree out of it?
Okay. Mm. So seems like if it should be deserialized, for example, if deserialized in the form of a binary tree. So yeah.
Like, go ahead, please.
No, go ahead.
I guess like we can generate it because we know the root node, we know the left subtree, either it has a value or it is empty. Okay, and then we know the right subtree. It's a good question. Like try it out, but the way like we are constructing, we can like constructing the string. We can again construct the binary tree based on the if given the string. Because what I think if the left node is empty and we are not inserting the empty brackets, okay, then in that case it is hard to figure out whether the left is empty or not. But in this case, I guess yes, we can generate it.
The idea actually was just to understand why they want the brackets and even the left empty string, but not in the right one.
Yeah, because we can't generate like because if we have given like this kind of a string, we would have done that. But based on this output, we need to see which bracket is closed and which is not, where it is closed. Yeah, that would be the logic. Thank you, Puneet, for sharing this. Do you have any approach in your mind while solving it?
The first one or the
This one.
serialization?
This one. Like
I think
deserializing.
the deserializing one?
Yeah.
Yeah, I think it is similar to how we construct a tree from pre-order and in order. The only difference in this case is you don't need a in order to tell you what's going to be the next node, what is going to be the next left or right node. Anytime you first take the first element, that will give you the root node. Bracket start will give you the left node, and you can recursively continue till you are able to see a closing bracket for that starting node, right?
Okay.
Because that's your stack problem, the matching parenthesis problem.
Yeah, got it. Like going for a left part unless you get some closing bracket.
Correct.
Okay. Okay. Yeah. That should work. Okay. So